Good evening, everyone. Please scan the QR code and do the event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. Also, you will be able to access links from today's session. I will share the event check-in link and the QR code again with the event ID in the Q&A section shortly. You need to enter the event ID which is displayed on the screen. Please do keep an eye on the chat section for further details. Thank you all again for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor. The session will run over the next 60 minutes including Q&A. The session is being recorded and will be made available to watch on demand on Microsoft Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Today we are back with the recommendation engine and Azure ML series part 4. In case if you have missed the previous sessions, please visit our Reactor YouTube channel to watch the recorded session. I would now like to welcome Amrish, our speaker for today's session. Amrish is a business and technology consultant for more than 20 years. He is currently working with TCS as the energy trading and risk management lead, as well as data analytics practice lead for TCS Utilities. But for now, I will hand over to Amrish to begin the session. Over to you, Amrish.
Thank you, Rashmita, for introduction. So let's start. So maybe what I'll do is that I will share the screen. So, so yes. So this is part of the recommendation series. So we have done the intro to Azure ML. We have done a recommendation engine with text data, TF-IDF, cosine similarity. We then deployed it in Azure ML in session 3. Now we are here. What we will do is that this is a pure session in which we are not doing any deployment, but we would understand the concepts of word embeddings and how that can be used for a simple recommendation engine. So what we will do is that the data that we are taking is from one of the competitions in Kaggle, the Career Village competition. So this Career Village is a community where students can get free personalized career advice from real life professionals. So the competition in Kaggle was something like this. So what they do in Career Village was people would ask questions, and then the system would guide it to the professionals who can answer the questions. So it is very important because some professionals would be able to answer some kind of questions, like uh, like if you ask like a music question to me, who is not a music expert, I'll not be able to answer. So it should route it to somebody who is a musician or is a music expert so that they can answer the question. Similarly, if it is a computer engineering question, it should be routed to a computer scientist or a computer programmer or whoever who is more engaged in computers. So here's a prelude of what we talk, what we have discussed, and what the Kaggle competition was that to develop a method to recommend relevant questions to the professionals who are most likely to answer them. So what I have done is that I have utilized the data set, but I've changed the problem statement a bit. So what the problem statement that I have changed it to is something like this. So we had the questions, we had the answers, and we had the professionals. There were several other data sets that was there. So what we did was that I took only the questions and the answers. Okay. So here, what we did was that, uh, say, suppose I'm given a question. So we would find the similar questions for a given question. And then we would find their corresponding answer and display the answers. So the example of which is something like this. So if I ask a question, I want to be a data scientist, what should I study? So I'll say, and I'll ask for recommendations. So what it would do is that this is a question. I would really try to find out similar questions in the knowledge base that I'm having from the Career Village data set, which has questions, answers, and professionals. We are not using those professionals, but we are using the questions and answers. So I would find a similar question for this. And then for that similar question, I would list down the top 5 answers. Okay. So here you would find hello Chong Ji. I'm not Chong Ji, but the answer had this. But so this would give a good thing that from the knowledge base we can find these question answers. Okay, so I can show you of how we are doing it. So what I have done is that I've got this Streamlit app running, which is there, and in my app I have two options: a TF-IDF and the word embeddings. So I'm not going to use a TF-IDF today. So let me just see. I just want to show you of the thing that is going on, and then we'll go into the internals. So you say here and then you make a recommendation. So this is a Streamlit app which has the code running there. So it gives you all these things. So this answer 1, this is answer 2, this answer 3. Similarly, if you change it maybe to maybe say something like a pharmacist or something. So it gives you the pharmacy related questions. Now, while I was doing this, I thought of let me try to fool around with this system. See, what it is doing is that it is trying to find a similar question answer. I'm trying to do something completely weird. Say, I want to do this. I want to be a robber. What should I study? Okay, let's see what it does. So obviously there is no such question in it. See, let's see how it finds. It's actually doing sentence similarity. So let's see what it does. You'll find very interesting things it is giving. I just tried it, this experiment. See, it is saying a degree in criminal justice will definitely help. This is just amazing, right? So, so if you understand this robber and criminal are close together, and that's how it is doing it. So you understand the uh, what should I say? the 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 way it is trying to do. We'll get to the internals and how it is doing it. We'll find that why it is giving this. See, study internship. Something is that why it is giving biology, we do not know, but it is giving all these things actually. Paralegal. See, it is trying to give you some kind of this is very interesting. I thought maybe I'll try to fool the system and see. So enough of the demo. So let's see of how it is doing it. So let me go back to my presentation. So this is about the demo and how it is going it. Now let's look at the internals. So here's the TF-IDF. So today we'll not discuss the TF-IDF. So we'll go here. So uh, here we'll just discuss some of the techniques that are there to convert uh, words into numerals. So basically, our program and it doesn't understand a word. Everything has to be converted to a number. So one of the techniques that people use is called one-hot encoding, which is like you have all the words. Say the cat sat on the mat, and then what it would do is that it would put a one when the word appears, and then others would be zero. Similarly, you see here, if I just use my pointer, so it is using a one here, then a one here for the cat, sat here, on here, the again here, and mat here. So if it's a sentence, you will have ones all over the place. But the problem with this is that if my question bank has around 50,000 questions, and 50,000 questions will have how many words you can imagine. say so many words. So this basically is constructing this huge matrix over here, and half of the time this huge matrix, what would happen for a sentence, half of it, more than half of it would be zeros. So it's a huge matrix, and it would be very difficult to handle it in programs. Obviously, we would use sparse metrics and all these things, but scaling wise, it is a problem. So this one hot encoding might work. And to be honest with you, I did try it in a competition. Somehow I made it work because the data set was not that huge, but somehow by restricting the number of features and so on and so forth, I made it work. But it's not a great solution. So the next step people would do is like a linear encoding, in which what they do is that they put a value to the word. The is becoming a value, cat is becoming another two, three. So what would have when the cat sat on the mat would have this type of a vector. So but the problem with this is that it has got no meaning as such. The words come in and you just assign it vectors. There is no relation between the words. So that is not a great thing to do. So what the next thing that people have done is called word embedding. So word embedding is that meaning there are models. What they do is that they have trained the models in such a manner that uh, the words, meaning these, they produce vectors of length say 100, 300, and so on and so forth. But the good thing is like uh, the similar words are closer to each other. That's what is uh, is a concept. Meaning, if you have a very popular example is that a queen is closely associated with a king. So the king and the queen will have a lot of similarity, while a queen and a princess will also have a lot of similarity. But a queen and a mother would have a little less similarity, and a queen and a teacher would have less similarity. So we'll show you of how it is done. But before I show you this concept, that similarity concept, I would also like to revise the concept of cosine similarity, because we would be using the similarity concept. And here I would just give you an introduction of cosine similarity. So cosine similarity is a very simple thing which you know it actually. I'll just try to refresh this. So basically, um, any point can be represented in two dimensions by two values, right? 8 and 5, it's a two dimensional value. Similarly, if it is a three dimensional, it you have a three dimensional value, right? X, Y, Z. Okay. And if it is four dimensional, it is four values, five values. If it's a 300 dimensional vector, like the one that we are seeing over here, it will have 300 values. So for us as humans, we cannot visualize this, but mathematically it is very sweet. It is just a vector having 300 values. And how we use a similarity? The similarity what we use is a cosine between the two vectors, which is actually meaning you, if you remember your high school maths, cos of 0 is 1, cos of 90 is 0, cos of 180 is minus 1. So cos of 0 is 1, meaning if the vector is very similar to the other vector, then the value would be 1. So higher the value, the vector is closer together. Okay. So this is what I am trying to say. And this is a maths behind it, some fancy math, but ultimately it comes to that. So if you are a little bit mathematically oriented, it is very simple actually. If you have vector, then it is AI, BI, and then you do a sigma, meaning it's a dot product and divided by a dot a, that is a square, and then you do a sigma and then a square root. Similarly for b, if you do it in a program, it is very simple. Meaning a dot b is at 1 star 1, 0 star 1, 1 star 0, 1 star 1. So that's sigma ai bi. AI square is all the more simple. You just multiply with itself, 1.1, 0.0, 0.0, 1.1, and then you put a square root. and you just use a dot b by a L2 norm star b L2 norm. So this is a very standard way. Anyways, I'm just showing you the internals of it. Ultimately, we won't be using all these fancy things. We'll use an sklearn function, which is a cosine similarity. But as such, if suppose you are wanting to do it by hand, maybe you're trying out, you're trying to write in a completely different language, which is not Python and which does not have, what should I say, these fantastic libraries. Maybe nowadays people are writing in Rust. Rust is another very fast language. People are writing in Rust. So Rust won't be having these sort of libraries. I do not know whether it has or not. You can, these concepts might help you. So this is about the theory. So I just want to go ahead and show you another thing is that let's do a demo actually. So here what I'll do is that uh, so so this is the word embeddings, and what we will do here is that for the word embeddings, so there are several word to vec and various pre-trained models are there, but what we will do is that we will use Spacy, which wraps and makes it very easy to use all these word embeddings. So check out Spacy. It's a very nice library and makes it very easy to do all these word embedding stuff. So here what I am doing is that I am using Spacy and I'm loading a large model. So Spacy has different types of models in which larger the model is larger the number of elements in the vector. So you see here the vocabulary that the word, how much is a vocabulary? It's around 684,000 words it has scanned, and each word is around having 300 features. So if you go back here, it's like this. Each word for the large vector, um, here it is. It will have 300 values. Okay. So let's play around. So just as I was saying, so let's make the vector for queen. So it's very simple. I load it and then I do a NLP queen. And I just want to show you, you can print out these 10 values. So these are all pre-trained models. So the vector shape is 300 and then I play around with it. You see, queen and the king, the cosine similarity is 0.72. Queen and mother is 0.44. Queen and princess is 0.657. So you see the queen and the king is much more than the queen and the princess, and the queen and the mother is very low. So this is what? So this is for a word. Okay, now I play around with something more interesting. So I make a sentence and see of how the sentence is similar to itself. So what Spacey will do for me is that it will take the vectors. Each word is a vector, right? Each word is a 300 dimensional vector, and then it would take the average and give me the sentence embedding. So we are going from word embedding to sentence embedding. Okay, so you see here what I did was, again I am playing around. So I have done, I am a software consultant, I'm a data guy, and I'm a plumber. So let's see if I do x1 x2, which is a software consultant and a data guy, it's 0.73. A plumber is 0.64. So you see it is giving me a sort of similarity here. So I just want to give the intuition of how beautiful we are with such simple things. Once we understand the concept, it is giving me this type of a similarity. So next is I play around more. So here I just thought, or maybe let's try out something which junk food kind of a thing. Pepsi, Coke, Sprite, chips, potato chips, and teacher. So Pepsi and Coke 0.655, Pepsi and Sprite 0.39. So Coke is having more similarity. Pepsi and chips 0.24. Pepsi and teacher completely different, minus 0.0091. Pepsi and potato chips is 0.29. See a chips and potato chips 0.29. So just want to give you a very what should I say, intuition of how am I going to use it. So this is what is the word embeddings concept. And now once we understand word embeddings, what we will do is that we will utilize this concept of word embeddings. You can utilize this concept of word embeddings in anything. So basically what you are doing is that given a sentence, I'm creating a vector. You can use this word embeddings for classification, for maybe sentiment classification, for any kind of classification you can do. And then you can put it in a neural network and you can do all sorts of things. But here, what we are doing, we are not doing anything so very fancy. We are doing a very simple thing. We are just using it for recommendations. So here what we are doing recommendations is that here we have a question, we have other questions. So what we will do is that we'll try to find the cosine similarity. So here what I have done is that this is the career village. So career village, what is it's having is that it is having a questions, it is having professionals, it has got answers. Okay, so the questions data is all here, and then there is a professionals data. I'm just merging all these things together to make one data set. Ideally, you don't require the professionals, but anyways, we have just done it. Question and answer would be fine. But then what I am doing is that I'm just taking the question's title and the question's body. So the question's title is something like this one, and this is a question's body. So these are the two things it is there. These two things, what I am doing is that I'm concatenating this and creating a question vector. So I'm doing a question vector here. Question vector is coming. And then I'm doing a very simple thing, the clean text, nothing very fancy. I'm just cleaning lowering the thing, removing the punctuation, and just removing the text white spaces. And then what I'm doing, so my questions is around 50,106 questions are there in my repository. So that's a huge lot of questions. And for each question, I have um, a vector. So it would be a vector that is for 50,000 questions. Next step is that I load Spacey, which has a pre-trained word embeddings for me. So Spacey has different kinds of word embeddings. You can go ahead and check out the Spacey website, spacey.io. So it is an industrial strength natural. You can check out this. It has got lots of things, but it's quite meaning it keeps up to date. So it has got transformer based also. This BART, Robota. I have not used that. I just use this I think it's using beneath word to vec. So obviously there is more improvement that you can do. So this is a word to vec type of a word embedding it is using beneath. And here what it is doing is that just like for each question I'm creating the vector. So previously it was word embedding. Now what I am doing is that that question becomes, I put it into Spacey and it gives me a 300 dimensional vector. So why it is giving a 300 dimensional vector? So what it does is that each word it is having a 300 dimensional vector and then it is averaging it out. So for each question I'm having a 300 dimensional vector here. And here I'm saving it as a pickle file so that I'm doing it in the same application. So it's not really necessary to pickle it. But if I'm using it in a different application, like I used in my Streamlit application, I have pickled it. And now what happens is that when a new question comes up, what I do is that I do that same vector again, the use spacey again to get a new vector. I load it my original vector, and then I do a cosine similarity with each of the 50,106 questions. So what happens is that I have given one vector and my repository has 50,000 vectors. So for each vector, I would do a similarity. I would calculate the similarity and I would place it. So this is where I'm placing it. So, and then what I do, so it's, if you see the result thing, which is a cosine similarity of all of them. So here what I'm doing is that once I get the cosine similarity for each of the questions, I am getting, and after I get the result, I'm getting the largest cosine value. That means one which is closer to 1 would be the one which is. So here, if you see the largest cosine values are 0.98, 0.98, 0.96. So here you see these values are coming up. So these are the highest values which are coming up. So this is in the Jupyter notebook, so it's not looking very nice, but you saw the demo. It's the same code which is happening, but in the Streamlit UI. So in summary, what we are doing is that we are loading the spacey, and once you load the spacey pre-trained model, then for each of the questions, I'm doing a word vector, rather a sentence vector for each of them. And the new question comes up, it's another sentence vector, and I'm doing a cosine similarity with each one of them and picking out the questions which has the highest similarity and displaying it to the user. So all this is going in a Jupyter notebook. So how to usually put it in production or something like that. So here, what I've done is that this is my whole app um, in Streamlit. There are different files because in this project I'm doing a lot of things. I'm pushing it to Docker, Kubernetes, and blah blah blah. We are not discussing those. We are just if you will use only this record.py. So the same code is here. The only difference here in this code is that I am utilizing this. I'm loading it from here, which I have stored the spacey questions is here. I'm loading it here and I am utilizing the same code and displaying it in a very nice manner. So the concept is the same, just I'm changing the UI and you saw of how it demonstrates. So this more or less completes the concept part of it. And um, this actually completes the whole session. Obviously, I have covered a lot of ground. I'll take a pause, take questions, and see of how it is going. So let me see for questions.
It's a good session, Mushi. So I
Uh,
think one question I have is that we are taking the sentence embedding as the average of the word embeddings, right?
yes, yes.
I think I mean if you look it from the average point of view, we can have average of four. Now 4 plus 4 average is also 4, and 6 plus 2 average is also 4 actually. But does it lose the meaning in between, or what are the other alternatives?
Yes, good question actually. So if I understood your question, so are you saying the average is distorting the meaning or something like that? That's what you're saying?
Yes, that's what I want to
Okay,
understand. Take
okay,
it average somewhere I mean, we may get the recommendation which may
hmm,
not be the one which we would like to see, right?
okay, okay. Might be if suppose um, maybe I'll have to see whether there is any smarter way of doing it or not. So that can be one part actually.
Sure.
Which one is more effective, engrams or word embedding? So word embedding is one technique which actually is is taking care of the contextual knowledge, and it is a pre-trained model, and therefore these models were trained on a lot of text, so that contextual similarity is is being used here, so that makes it a little bit more attractive in this case. So I would say word embedding is better than an engrams, I would say. Mm. If anybody has any other answer, would also like to know, because to be very honest with you, I am no expert in recommendation systems, but this technique that I've seen is that I've used it uh, partially in some competitions and it was appreciated, and I am seeing that this type of thing is being appreciated in one of the career village competitions. One of the winners also used it, and there was another competition that was in Kaggle, um, for they launched a competition in which they want people to find out relevant material for COVID-19, so a kind of a search kind of thing. So this was used. So they didn't they used some other types of embeddings, which Yogesh was saying, right? Sentence embedding, they used the TensorFlow sentence embed encoding thing. So that I think was the person said was much more better than this type of embedding. So this is actually a huge subject. So just I remembered. So that TensorFlow embedding was sentence encoder was slightly better. So I have to see what is going on inside it. Okay. Okay. Today there is very less. There are 10 people. Okay. Did I miss any questions? Okay. Consider I have a case of receipt classification. What should I use to provide? So you can use this word embedding itself, and you can use engrams and see of how it is performing. See, in machine learning and deep learning, one of the good things is that it is I would say my feeling it's more of an empirical science. So try both of them. Try engrams, try word embedding. I would say try even pure TF-IDF and see of how it is working. But once you get the concept and the framework correct, then trying it out is becomes very easy. So I just want to, since there is more time, I just want to show you something more interesting that I was playing around. So in Kaggle, if you take this concept and extend it a little bit, in Kaggle I was just playing around. So So here, see, this is another thing that I was trying playing around. See, this I had used tweets prediction using conv 1D and word embeddings. So I have not discussed conv 1D, but many people here are there and experts. Yogesh is a Google developer expert in machine learning. So there are more experts than me here. So you can try this out here. What I'm doing is that I'm using TensorFlow with word embeddings. Did I use Spacey here? Yes, I use Spacey here. So for me, so the problem is like this. Let's go back rather than me jumping into it. So it is natural language processing with disaster tweets. Predict which tweets are about real disasters and which ones are not. Okay, so there are tweets coming in, and you have to predict that whether it is a real disaster or not. So what you can, so the data is here. It's actually getting started competition. There is a train and a test. Okay. So how does the data look like? So the data has got ID, keyword, location, text. Okay. So these are there. So I did a very simple thing. I used, I think, text and keyword. Okay. These two things. So similar way the sentence embedding I worked. So here the only difference was that it is not a similarity problem. It is a classification problem. So the classification is that whether it's a disaster tweet or not. So they have got a target here. So 1 or 0 or something. Okay. So here what we did was that if the concept is very similar. So this is not part of our actual talk, but since we have some time, I just want to show you of how easy it is. Once you get the concept correct, it's very easy to play around. So much of things that I tried. So here also what I'm doing is I'm taking in the text and blah, 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 cleaning the text, nothing very fancy, target, blah. And then you see here, I'm doing a text vectorization and so that I get all these things, I'm creating an embedding vector, and then an embedding layer. So maybe this demands another class, but ultimately you see, once you get this embedding correct, then I'm just using a neural network here to get whether the tweet is classified correctly or not. So here's the thing. So it gives more or less a validation accuracy of 7855. Maybe if you're interested, we can go sometime in depth in this. So what I wanted to give you the fact is that this concept, once you know this word embedding concept, you can use it in different areas like classification, like Rajat has asked, right? So that you can use. Yes, it's like BERT also is also like rightly Yogesh has said that BERT, yes, because BERT is much more advanced. I do not know much about BERT, but I think it takes more more information about the sentence as a whole rather than the word. So BERT would be a good technique to use. Is only 22 receipt. Okay. Yes. Can use a TF-IDF and see that might perform a little bit better maybe. Mm. So I think Yogesh has given a lot of answers in it. So you can utilize all these techniques. I would say TF-IDF, Spacey, BERT, and all these things. You can go ahead and use all these things. So any more things? Another thing, this is word embedding. You can also explore, since we are talking about embeddings, another concept is called entity embedding, in which what happens is that if you have a lot of a feature which has a lot of categories, right? And you want, if you use one hot encoding, the matrix would become very huge, right? So you can use something which is called an entity embedding. And what it would do is that, as in the word embedding, we reduced the whole vocabulary into a 300 dimensional vector. um, there also you can reduce, if you have very sparse categorical features, you can reduce it to a much lower dimensional vector, and that you can use in your neural networks, in your programming. So this embedding concept can also be used in other places, not only in word. So Rashmita and Vivek, if there is no more questions, then we can call it a wrap.
Yes,
Sure,
Amrish.
Amrish. Thank you so much,
Yes,
Amrish.
yes. I just
For
want to thank you, everybody. And also, one thing is that I have started one YouTube channel, kind of self promotion on my site. So here it is. So if you want, you can subscribe to it and um, started one playlist which is kind of a little bit interesting in the sense that uh, what I have done is that there is an intro to deep learning, and then this is how you would build a deep learning model, very simple stage. And then the only difference is that you will find it in different places scattered all over the place, is that how once you have a deep learning model, how you would deploy, you will make a container image, how you will make a Kubernetes application out of it, how you will deploy it to Azure container instance, deploy it in AKS. That is one part, and I am trying to extend it also to other cloud providers like AWS and Google Cloud. So, anyways, if it interests you, please do have a check out the videos. I have uploaded quite a bit, and I plan to upload more. So that is one part I just wanted to share with all of you. Yes, thank you everybody for attending this session and asking very interesting questions. Appreciate your time.
Yeah, bye all. Thank you.